Hi everyone, it's Miss Costa, and in this video we're going to be going through the Edexcel Higher Paper 2 for the June 2022 series. Okay, so we're starting off with a simplifying question. So we've got index laws. Now, the law of indices states that when indices are in brackets, I multiply the powers. So if I had x to the power of n to the power of m, that would become xn times m. So all I would do in this case is do 3 times 5, which is x to the power of 15. But just in case this is a little bit confusing to you, I will show you why. So x cubed is being multiplied by itself 5 times. All indices mean are how many times that variable is being multiplied by itself. So x cubed, what does x cubed mean? It means x times x times x, and x cubed to the power of 5 means x cubed 5 lots of times. So if I did this 5 times, I'm just going to summarize it to x cubed. So x cubed times x cubed times x cubed times x cubed. Using the laws of indices, when you multiply indices, you add the powers. So 5 lots of 3 would give you x to the power of 15. I could expand this even further if you really wanted to. So write out x times x times x 5 times, and then you see exactly why x times x times x. It's a slightly laborious process, but here we go. So here you go. You see why x is written to the power of 15, because it's being multiplied by itself 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 times. So when we are multiplying powers, it's just a shortcut way of writing it. Instead of writing this long thing out, we write x to the power of 15. But the shortcut is multiply the powers when you are dealing with indices in brackets. Next, we've got expand and simplify. So here you've been given 2 sets of brackets. So what we want to do, because they're not being multiplied by each other, they're separated by an addition, we're going to do these separately. So over here you can see they are being separated. They're 2 separate sets of brackets. So we multiply the first bracket. 4 times x is 4x. 4 times 3 is 12. And then 7 is a positive 7, because the sign always belongs to the term after it, so the plus belongs to the 7. So 7 times 4 is 28, and 7 times by negative 2x is minus 14x. So now we have expanded them and we need to simplify. So we collect the like terms. 4x minus 14x becomes minus 10x, and 12 plus 28 becomes 30. Now, I'm just going to rearrange this because it's just nice to start with a positive number. So 30 minus 10x is exactly the same thing, as long as you keep this sign belonging to the 10. It doesn't matter what order you put them in, because addition and subtraction, as long as you state what is happening, it doesn't matter what order they're in. So final answer would be, oh, and I realized that that should be 40, because 12 plus 28 is 40. Your final answer should be 40 minus 10x. If you left it as minus 10x plus 40, that's fine, but it's just a lot better to write your algebra with a positive term at the beginning. So the last part of question 1 is asking you to factorize something fully. So what you can do, if this question is something that you find a little bit tricky, is think about what the algebra is doing and go from there. So the first thing I want to do is split up my terms into finding out what the algebra is actually doing. So that's 15 times by x times by x times by x plus 3 times by x times by x times by y. All I'm doing is I'm breaking it up into its purest form. If you wanted to be even more accurate, you would think, okay, so I've split up the algebra into its pure form. Now, can I split up the numbers into their pure form too? So into their prime factors. So I've got 3 times 5 makes 15, and 3 is just itself. You don't have to split it into 3 times 1 because it's a prime number. So you're then left with 3 times 5 times x times x, and 3 times x times y. Now what you want to do when you factorise is you want to look at the two terms and pull out the highest common factor of both of them. So anything they have in common you pull out and you put that outside of the bracket, and anything that's left goes inside the bracket. So I know I'm going to put things in brackets, and I'm going to pull out the largest thing they have in common. So they've got 3 in common, so I can put that outside the bracket. Then they've got x in common, so I can put that outside the bracket. And there's another x in common, so I can put that outside the bracket as well. Then all I'm left with for the first term is 5 times x plus y. Now what I want to do is simplify that. So that would be 3x squared brackets 5x plus y. So I've pulled out the largest common factor from both of the terms. And that's how I'd do this question. Obviously I've broken it down into lots of detail. You can also just do it really quickly just by knowing that x squared is the largest factor, but this is how you do it if you struggle with this question. Okay, for question 2, we are being asked to describe the single transformation that maps shape S onto shape T. Now, this kind of question people frequently get wrong because they don't read it, so they describe multiple transformations. So it's a single transformation that maps shape S onto shape T, and if we look at it, it has moved, so it's most likely going to be a translation. So let's have a look. When we're looking at translations, we pick a point over here. Let's pick this point. So that's the bottom point. Oh, actually, it says that maps shape S onto shape T. So that's another place people go wrong. Start from where they tell you to. So we want to map shape S. How do we get from shape S to shape T? So let's pick a point on shape S. So I'll pick this point, 1 minus 3. And what do I do to move it to shape T? So I can say that it is a translation because it is a movement. And then what I need to do when I'm talking about translations is say that it's going through the vector and then find out what the vector is. So to find out the vector, I look at the, whenever you're writing vectors, you write the x value at the top and the y value at the bottom. If the vector, if the movement is going up or to the right, then it's positive. If it's going down or to the left, it's negative. So let's have a look at what's happening here. To get from here to here, let's do the x-axis first. What am I doing? I'm going across 1, 2, 3, 4, 5, and I'm going left. So that's going to be a negative 5. So left is negative, right is positive. So left is negative, right is positive. And then you want to look at your y translation, so how much it's moved. So it's moved from negative 3 to 1, 2, 3, 4, 5, 6 squares up. So you're going to say it's a translation through the vector minus 5, 6. Remember, going up is positive, going down is negative. So an error interval question, all that it's asking me to do is to, if something has been rounded to a certain amount, what's the minimum possible value it could have been and the maximum possible value that it could have been. So I'm told that the length of a football pitch is 90 meters, correct to the nearest meter. Okay, so what's the maximum it could have been? Well, to the nearest meter, if it was rounded to the meter above, it would have been 91 meters, and the meter below would have been 89 meters. So my error interval, the absolute minimum it could be before it would have been rounded down, is 89.5. Because if it was 89.4, it would have been rounded down to 89 meters. So I know that the minimum it could be is 89.5. And then the maximum it could be, now this is a point of contention. We generally go with just saying, so I'm going to say 90.5 is the midpoint. Now, obviously, with normal rounding, 90.5, that would round to 91. But what happens is the absolute maximum value it could be would be 90.49999 recurring, going on until infinity. If you wrote this, that would also be fine. But generally, what we do is we just understand that because it is a bound and because this sign over here says less than, we write 90.5. Okay, so instead of saying is less than or equal to 90.49 recurring, we just round it to 90.5, but we know that it's less than, so it can be anything up to that value. So this is a population density question. In this case, maybe an area density because it's not an entire population of a country. So we are told that festival A will be in a rectangular field with an area of 80,000 meters squared. So festival A is 80,000 meters squared. And the greatest number of people allowed to attend the festival is 425. Festival B is going to be in a rectangular field, 700 meters by 2,000 meters. So 700 by 2,000. And the greatest number of people allowed to attend is 6,750 people. The area per person allowed to festival B is greater than the area per person allowed to festival A, and I need to find out how much greater and then round it to the nearest whole number. So what I need to do, first of all, I haven't actually been told the area of festival B, so I need to work that out. So 700 times 2,000 is 7 times 2 is 14. Oh, this is a calculator paper actually, so you could have worked it out on a calculator, but we didn't, we did it in our head. So that would be 1,400,000 people. Sorry, 1,400,000 meters squared. Actually, I'll get my calculator to help with the next bits. So what I want to do to figure out how dense the population is, or how much area each person is allowed, I will do 80,000 divided by 425, which tells me the area for the first field. So 80,000 divided by 425 is, I don't like these new calculators, so 188.235, 188.235. And then I do the same for festival B. So 1,400,000 divided by 6,750 is 207.407. So I need to find out how much greater this is. So I'm going to subtract my 2. So 207 take away 188.235 leaves me with, so 207 ... take 188. I do type in the whole number into the calculator, I'm just not saying it. Leaves me with 19.17240. So it says give your answer correct to the nearest whole number. So that would be 19. Okay, so the area allowed per person for festival B is 19 meters squared more than for festival A. So it sounds like they're much less tightly packed in there. The next part of the question says, Callum says 300 centimeters squared is the same as 3 meters squared because there are 100 centimeters in 1 meter. So you divide by 100. Now this question is a little bit annoying because they give you something that's true, and then sometimes people focus on that. So yes, it's true that 1 meter is 100 centimeters. However, that's not the same case for the area. So if you think about the area of something that is 1 meter by 1 meter, how would you work it out? Well, you do 1 times 1, which is 1 meter squared. Okay, so 1 meter squared is 1 meter by 1 meter. But let's convert that into centimeters. What is 1 meter in centimeters? it's 100 centimetres. So if I were to work out the same area, I'd have to do 100 times by 100 if I were working it out in centimetres. And 100 times 100 is 10,000. So 1 metre squared is actually 10,000 centimetres squared. So I would have to say that Callum's method is wrong because 1 metre squared is 10,000 centimetres squared, or to turn metre squared into centimetres squared, you multiply by 10,000. Or you could say by 100 and 100 again, because it's an area, so it's a dimension. So it's 2 dimensions you're multiplying by each other, not just one. So for linear things, yeah, for like working out the length of something, you would just divide by 100. But for an area, you're going to have to divide by 1,000. So there. So question 5 is working with a straight line and coordinates. So the points L, M and N are such that LMN is a straight line. The coordinates of L are -3, 1, and the coordinates of M, so I could just plot L here, are 4, 9. So 4 is going to be in the positive direction, 9 is also going to be positive, so M is going to be here, roughly. Now, given that L to M, oh, and then we have N as well, so N is going to have to be up here somewhere. Given that L to M is 2 to 3, find the coordinates of N. Okay, so what this means is that the distance between L to M is 2/5 of the distance of the total distance. So remember, when you've got a ratio, that means 2 parts to 3 parts. So LM, that distance is worth 2 parts. So let's actually figure out what that distance is. So let's figure out the X distance first. So the X distance from -3 to 4, that's a distance of 7. And the X distance is 7. The Y distance is going to be from 1 to 9 is 8. So I know that one part of this ratio, one part of this little distance is going to be 3.5 for the X value. So therefore, the total distance, if one part is 3.5, 5 parts, 1, 2, 3, 4, 5, which is the whole line, is going to be 3.5 times 5. Now, if I work out 3.5 times 5 in my calculator, that is 17.5. Okay, so that means I'm going to move 17.5 up from my original X coordinate. So -3 plus 17.5 is 14.5. So the X coordinate will be 14.5. -3 plus 17.5 is 14.5. Okay, so all I've done is I've looked at the ratio elements. I know that the X element is 7 across, so I've done this for the X part. Now I do exactly the same for the Y coordinate. So I know, what did I say the distance was? Oh, okay, I have it here. Y equals 8. So once again, I've got 2 parts to 3 parts. So if 2 parts are worth 8, that means that each part is worth 4. So that means that 5 parts, if one part is 4, 1, 2, 3, 4, 5 parts are going to be 4 times 5, which is 20. So I know that the distance is going to be 20 more than my original Y value. So 1 plus 20 is 21. And that's one of the ways that you can do that. There are so many ways to do this question, but the key is understanding how a ratio works and how you're just literally splitting up the line and go from there. Okay, so in this question, we are told that a new phone costs £679 and that the value of the phone decreases at a rate of 4% per year. So work out the value of the phone at the end of 3 years. Now we could do this a long way where we work out 4% of 679, subtract it, work out 4% of that new value, subtract it, work out 4% of that new value and subtract it. or we could use compound interest. So my original value of the phone is 100%, but it decreases at a rate of 4% per year. So to work out my multiplier, I do 100 take away 4, which is 96%. Now what does percent mean? It means out of 100. So 96 over 100 is 0.96, but you can do all this on your calculator. So the multiplier is 0.96, and whenever we're doing compound interest, we do the original value times by the multiplier to the power of the number of years. So in this case, I'm going to do 679 times by 0.96 to the power of 3. So in my faithful calculator, 679 times 0.96 to the power of 3, that gives me 600.7357. 600.7357. So obviously money, so I'm going to round it to the nearest to 2 decimal places. So that would be £600.74. So a worded question, but all I need to do in cases like these is read the question very carefully and highlight the important parts. So I'm told that in Spain, Sam pays 27 euros for 18 litres of petrol. So I know that 27 euros is 18 litres of petrol. In Wales, so this is Spain. In Wales, Leo pays £40.80 for 8 gallons of the same petrol. €1 is 85 pence and 4.5 litres is 1 gallon. Sam thinks that petrol is cheaper in Spain than in Wales. Is he correct? So there are loads of ways that we could do this question depending on which you do first. I'm just going to show you one way that I would do it. So first of all, I would figure out how many euros does a litre of petrol cost in Spain. So what have I done to go from 18 litres to 1 litre? I've divided by 18. So I need to do the same thing to the other side because this is all in direct proportion. So 27 divided by 18 is 1.5 euros. Okay, so 1 litre costs 1.5 euros. Now, I also know that 1 euro equals 85 pence. So therefore 1.5 euros, what would I do? I've times 1 by 1.5, so I'm going to times this by 1.5. So 0.85 times by 1.5 gives you 1.275. So £1. I'm going to just write the full amount for now. Okay, so therefore I know that the cost of petrol is £1.28, but let's just write the full amount here just in case there's a very close comparison with the next one. In Spain, that's how much it costs. So let's now figure out what's happening in Wales. So in Wales, £40.80 is for 8 gallons. So let's try and work out the cost of 1 gallon. What do? Well, I've divided 8 by 8 to get to 1. So I'm going to have to do the same on this side. And then I'm going to do £40.80 divided by 8 leaves me with £5.10, or well, 5.1 in your calculator. So you realise that that must be £5.10. Be really careful with these because they always get you out on these questions as well. So £5.10 is the cost of 1 gallon. Now I know that 1 gallon is the same as 4.5 litres because this is the information they've told me here. So therefore, to work out how many litres it is, I could times by 4.5. So £5.10 times by 4.5 gives me 22.95 litres. Sorry, £22.95 for 4.5 litres. And now if I want to figure out, oh, sorry. 1 gallon is equivalent to 4.5 litres. So what I want to do is divide by 4.5 to figure out how much 1 litre is. I'm quite tired. So 1 litre, I am going to divide by 4.5 on both sides. So £5.10 or 5.1 divided by 4.5 gives you 1.13 recurring. So £1.33 recurring. So therefore, the question is saying Sam thinks petrol is cheaper in Spain than in Wales. Is he correct? Yes. £1.28 is cheaper than £1.33. So this question is about using a calculator. Now the annoying thing is that everyone has a different kind of calculator, but if you have one like this, what you do is you open up your fraction button over here. Oh, I double did it. Okay, so then you can input everything bit by bit. So you put the cubed root, which you press shift and then the cubed root, and then you'd input 1.57. Oh, sorry. 1.57 to the power of 4 plus tan 60, and then you close the brackets so it looks like that. Then you divide that by 7.2 to the power of a half. Now hopefully you know that a half is 0.5. It just makes it a little bit easier to type it into your calculator. You press equals, and then you get this really long display. So when you are asked for a use your calculator question, you want to actually write everything that is in your calculator. So 0.393379403. And then it says give your answer correct to 3 significant figures. So that just means 3 digits when the first one is a non-zero. Not zero. So like this does not count as a significant figure because it's before the number technically starts. The first non-zero digit is your first significant figure. So this is your first significant figure, second and third. So this is what we would be rounding. So that becomes 0.739 because 3 is less than 5. So we round the number down or keep it as it is. Okay, so in this question, we are dealing with pressure, and we are told the formula for pressure is force over area. So a box in the shape of a cuboid is placed on a horizontal floor. The box exerts a force of 180 newtons on the floor, and the box exerts a pressure of 187.5 newtons per meter squared on the floor. Now the face in contact with the floor is a rectangle of length 1.2 meters and width x meters. Interesting. So what we want to do is work out the value of x. So I know that the pressure, which is 187.5, equals force, which is 180. I'm just substituting the values that have been given to me here, divided by the area. Now, how else can I write the area? Well, 170.5 equals 180 divided by the area of this. How do you work out area? It's length times width. So 1.2 times by x, which is 1.2x. So the area I can write as an algebraic expression, which is 1.2x. And now what I need to do is rearrange the equation. So the little trick is, if you've got the subject over here, basically if you've got a denominator and a single term here, you can just flip them to rearrange it. The long way is you multiply 1.2x by both sides. So you end up with 187.5 times by 1.2x equals 180. And then you divide by 187.5. So you end up with 1.2x equals 180 over 187.5, which is the same as if I just flipped them. So that's a little shortcut, but this is why, so that you understand. So now what am I left with? Well, x is going to be 180 over 187.5 divided by 1.2, because the last step is you'd want to divide both sides by 1.2 because you want to get x on its own. So we've got a calculator. So 180 divided by 187.5 divided by 1.2 leaves me with 0.8 or 4/5. So x is 4/5 or 0.8, whichever you prefer, they are equivalent. And that's how we do that. So in this question, I am told that the box plot shows information about the sales in thousands of pounds of an online store each month. Andrew says 3/4 of the given data lies between 160,000 and 350,000 because these are the values of the lower quartile and the upper quartile. So let's see what he's saying. So let's check, is the lower quartile, this is the value of the lower quartile, and yep, that is indeed 160,000 pounds. This is the upper quartile, and that is 350,000 pounds. So the lower quartile is always going to be the last bit, or the first bit of the little box plot, and the upper quartile is always the top bit of the box plot. So he's correct in that, but he's saying that this means that 3/4 of the data lies between this. So the upper quartile is the top 75% of the data. This is where the 25% mark lies. So the difference between 75% and 25% is 50%. So the interquartile range represents the middle 50% of data. So that is why he is wrong. The interquartile range is half of the data, not 3/4. This is a quarter over here of the data. This is a quarter, this is a quarter, and this is a quarter. So, sorry, Andrew, he is wrong. The interquartile range, which is the difference between upper quartile and lower quartile, is always telling us the middle 50% of the data. For the next question, I am being asked to draw my own box plot. So a box plot generally, just to recap, is going to have these key points. It used to be called a box and whisker diagram, and these little parts used to be called the whiskers. So this last point is the least value. This point is the greatest value or the most value. The middle line here, that's going to represent the median. This line is the upper quartile, and this is the lower quartile. So that's how we label our box plots. So our least value is 30. So let's figure out what this is going up in. So it looks like, there's 10 boxes in between 0 and 100. So each little box must represent 10. Oh, this is a key place people go wrong. Please, please, please look at what is happening on your box plot. Find the difference between two values. So in this case, the difference is 100, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes. So that means that each little box represents 10. So anyway, the least value is going to be 30. So 1, 2, 3, I'm going to put that on 30. The greatest value is 350. The median, so I can make these a bit bigger if I want, just to differentiate them. The median is 170, so this would be 150, 60, 70. The upper quartile is 260, so that'd be here, and the lower quartile is 80, so that would be over here. Now you join together your upper quartile and your lower quartile and median, and that's the middle 50% of your data, and then you join the rest up with a straight line. Okay, obviously you're going to do it with a ruler and much neater, but that's how you do your box plot. Okay, so this question is comparing the distribution and it's another one that people frequently get wrong because they don't know what to do when you need to compare data. So we're comparing the distribution of the sales of the online store, which is here, with the distribution of the sales in the shop. So when I'm comparing the distribution, there are two things that I want to compare. The first is the median, and the second is the range. Now this can be the whole range or the interquartile range. It's interquartile range or the range. So a lot of people seem to know this, but what they do is they just state the median. So they're like, the median of the online store is 200, the median of the shop is 170. That is not comparing, that is just stating. This question does not say state, it says compare. So first of all, we've got the median of the online store, which I just said is 200 for the online and 170 for the sales, for the shop. So the statement I would write is the median for the online store is greater than that of the shop. And you can put your values in, so 200 versus 170. Okay, so you were saying that the median is greater because if the median is higher, that generally means there's more sales. So the median for the online store is greater than that of the shop, suggesting that there are more sales. The second thing we want to do is compare the range. So the interquartile range of this one is 160 and 350. So the interquartile range is 190. 190 online. I'm just going to double check that because it's holiday flu season. 350 take away 160 is 190. Okay, I'm not going insane. And then the interquartile range for here would be 260 take away 80, which would leave me with 180. So it's just slightly greater on the online store. So, okay, so a higher median suggests that there's a higher overall score. So in terms of sales, that's good because the higher the median, the more sales that you have. Now, when it comes to range, what that tells you is how consistent the data is. So we could say that the interquartile range is slightly less for the shop. Give our numbers, 180 versus 190, suggesting the sales are more consistent. So what the range tells us is you might have one sale for like $1 million, but if that's a one-off, that's not representative of the general data. So the range tells us what the general, like what the middle 50%, well, the interquartile range tells us the middle 50%. So it tells us how consistent the data is in the data set. So you use the median to say overall, generally, and then you use the range to compare the consistency of the data. Okay, so that is what you need to say. You cannot just state the numbers, you must compare them. Okay, so in this question, I'm told that Kieran has 13 workers he can use for a job. He knows that 6 workers would take 14.5 days to complete this job. Show that Kieran has enough workers to finish his job in less than 7 days. So I know that 6 workers take 14.5 days. This would mean that 1 worker would take, now this is inverse proportion because obviously the more workers you have, the quicker the job will get completed. So 6 workers, I would divide by 6, and because it's inverse proportion, I would do the inverse. So I would times this by 6. So 14.5 times by 6 gives me 87 days. So one worker would take 87 days to complete this job. Now he has 13 workers. So how do I get from 1 to 13? I times by 13. Therefore, I'm going to have to divide by 13. So 87 divided by 13 is 6.692. 6.692 days. And 6.692 is less than 7 days. So he has enough workers to finish this job by 7 days. Okay, so here I am given the equation of two lines, and I'm asked to show that these two lines are parallel. Now the key thing that we need to know is that parallel lines have the same gradient. So what I need to do is show that these two lines have the same gradient. Now the first line is arranged in the form y equals mx plus c, where m represents the gradient. So the gradient of line 1 is 2. So what I need to do is show that line 2 has the same gradient. So unfortunately this line is not rearranged in the form y equals mx plus c, so it's my job to do that. So I know that 5y minus 10x plus 4 equals 0. And what I want to do is rearrange that. So 5y would equal 10x minus 4. I've just added 10x and subtracted 4 from both sides. And now to get it in the form y equals, I'm going to need to divide each part by 5. So y equals 2x minus 4/5, which means that the gradient of line 2 is also 2. So both have a gradient of 2, therefore they are parallel. Okay, in this question I am asked to enlarge the shaded shape by scale factor -2 with centre of enlargement 0, 0. So my centre of enlargement is here, and a negative scale factor, it just means that you are going in the opposite direction. So normally I would expect to be going in the same direction, but I'm going to reverse the direction. So from the centre of enlargement to my first point, what do? I have gone down 2 and across 1, 2, 3. So what I'm going to do instead is instead of going down and across, which is how I would get from my centre of enlargement to the shape, I'm going to do the reverse. So I'm going to go across 3 and up 2, and it's a scale factor of -2, so it's double that. So I go across 3, up 2, and then I go across 3 again and up 2, and do that once more. So across 3, up 2. So my first coordinate would be 6, 4. The reason I've done this is because from the centre of enlargement, I need a distance of double whatever the distance is to the centre of enlargement. So I can choose another point. What am I doing? So this is the point -5, 2. So I go across 5, up 2. So I'm going to go across 10 and up 4. So the next point would be 10, 4. And I can join these together. Let's try another point. So over here, I would have gone down 4 and across 2. Instead, I'm going to go across 2 and up 4. And I'm going to do this twice. So across 2 and up 4, across 2 and up 4. So this would be that point. And the final point over here, I would have originally gone down 4 and across 6. So instead, I'm going to go across 6 and up 4 from my centre of enlargement. So across 6, up 4 across 6 again, and up 4 to here. So my new shape is over here. And that's how I do a negative enlargement. So wherever your center of enlargement is, if it was a -1, it just would have been the same distance, but it's -2, so it's double the distance from the original shape, but reversed onto the other side. Okay, so this kind of question is a capture-recapture question, where we're trying to work out the estimate of a population based on capturing some, in this case, fish, tagging them, releasing them, and then on another day capturing an amount, and the proportion of the amount that have been tagged versus over the proportion that have been caught gives us a rough estimate of what the population must be if we compare it to how many fish we caught on the first day. So Saffron wants to work out an estimate for the total number of fish in a lake. And this is the key. This wording is key to the fact that it's going to be a capture-recapture question or estimating populations. Now on Friday, Saffron catches 180 fish from the lake. She puts a tag on each of these fish and puts them back into the lake. So she has caught 180 fish, and they are out of the total amount of fish, which we don't know. We can just call that N. On Saturday, Saffron catches 305 fish from the same lake, and she finds that 45 of the 305 are tagged. So we can write that as a fraction as well. So 45 of them have been tagged. So originally she tagged 180, she released them back into the wild, and then 45 have come back as being tagged. So the idea is that they spread out and disperse among the lake, and then you can compare the proportions. So we've got two fractions that we want to just rearrange. So the quick way of rearranging, what do we want to do? We want to make n the subject, so we can multiply both sides by n. So 180 is 45 over 305 times by n. And then what do we do to get n the subject? We would say n is 180 divided by 45 over 305. We're just rearranging the subject. There's lots of ways you can do this to figure out what n must be. But in the end, once we do this, we would get 1,220. Okay, so this is a ratio question, except I've got some unknown things in this question. And whenever you have an unknown, you're going to want to incorporate algebra into it. So I'm told that the ratio of Marta's hourly pay to Khaled's hourly pay is 6:5. Now, both Marta and Khaled get an increase of £1.50 in their hourly pay. And the ratio of Marta's hourly pay to Khaled's hourly pay after this increase is 13:11. So they're asking me to work out the hourly pay before the increase for Marta and Khaled. So what I can do is set myself up an expression. So Marta's hourly pay to Khaled's hourly pay would have been 6x to 5x, okay? But they have both got an increase. So they both get an increase of £1.50 in their hourly pay. So I would say that's 6x plus 1.5 to 5x plus 1.5. Okay, so that's the new expression for their hourly pay after this increase. And I know that that is equal to 13:11. So their original hourly pay was just 6:5, but now it's this, and it's equivalent to 13/11. Now, whenever you have an algebraic expression and a ratio, you can make them equivalent in fractions, but I'll just show you what I mean. So if I had if I had the ratio 3:5, I jumped the gun and turned it into a fraction. So if I had the ratio 3:5, I could say that that is, I know that that is equivalent to 6:10, because if I multiply everything by 2, they're equivalent. So I know that they are equivalent. And if I turn this into a fraction over itself, so 3/5 is equivalent to 6/10. Okay, so normally when we're dealing with ratios, we'd be like, oh, that's 3/8 of the total, and that's 5/8 of the total, and that's absolutely correct. But when you have two ratios that you know are equivalent, you can turn them into fractions. So that's a key thing that a lot of people don't know or don't realise. So knowing that these are equivalent, I can turn this into two fractions. So I've got 6x plus 1.5 over 5x plus 1.5 must equal 13 over 11. So now I've got two fractions and I can just manipulate them in order to solve this. So what could I do? Well, if you know the shortcut way, you know that you're just going to multiply this and then by this, but if you don't, I'm just going to show you why. So the first step we could do, because we don't want a denominator, we want to solve it for x, so we're going to multiply both sides by 11. So that would end up being 11, 6x plus 1.5 over 5x plus 1.5 equals 13. Now the reason I only multiply the numerator by 11 is because what am I actually doing? I'm multiplying it by 11 over 1 as it's a fraction, and when you multiply fractions you only multiply the numerators by each other and the denominators. So that's just a quick reminder as to why that would be the case. And then what do I do? Well, then I'm going to move over and do the next part. So I've got 11 bracket 6x plus 1.5 over 5x plus 1.5 equals 13. And I'm going to want to get rid of the denominator, so I'm going to multiply both sides by 5x plus 1.5. Oh, that's a funny 5x. So I'm left with 11 brackets 6x plus 1.5 equals 13 brackets 5x plus 1.5. Now I've got myself some brackets. What can I do? I can expand them. So I've got 66x. I'm just going to use a calculator. So 11 times 1.5 is 16.5 must equal 13 times 5 is 65x plus 13 times 1.5 equals 19.5. Okay, so I've expanded my brackets just by going like that, and now I want to simplify. So I've got 65x here, I can subtract that from both sides. So I'm left with x plus 16.5 equals 19.5. And then what do I do for my last part to just find what x is? I'm going to subtract 16.5 from both sides. So I'm left with x equals 3. So I've set myself up an equation. I've made it equivalent to the new ratio. I've manipulated everything in order to solve it. And now I know that x equals 3. So if the original ratio was 6x to 5x and x is 3, then I'm going to do 6 times 3 to 5 times 3. So the ratio would have been 18 to 15. So Marta would have got paid £18 and Khaled would have got paid £15. So here we've got a Venn diagram question, and these are super fun. They're just like Sudoku. They're just like filling in things and using the information that you have been given to try and find the missing piece. So let's have a go at this. A shop manager wants to advertise special offers on social media platform. The manager asks 100 customers which type A, type B or type C they use. Of these customers, 4 use all 3 types. So there's my first piece of information that I can put into the Venn diagram. 4 use all 3. So if something uses all 3, it has to be at the intersection where all 3 intersect. So all 3 of these circles intersect here. So I'm going to put my first piece of information in the middle. I'm then told that 16 do not use any of type A, type B, or type C. So if they don't use anything that is in the Venn diagram, they need to sit in the little universe outside of the Venn diagram. So we're just going to place 16 over here. Sorry. 8 use both type A and type B, but not type C. So over here, this is the overlap, of A and B, and this would be things that were C as well. So 8 use both type A and type B, but not type C. So therefore I put 8 in there. So let's just tick off all the ones that I've done. Okay, 14 use both type B and type C. So over here you've got type B, over here you've got type C, and the space where they would use both of them, this is dangerous, will I be able to undo what I've done, would be this part here, this intersection here, because that intersects B and C. Now, I already obviously have, oh, I knew that would happen. I already have 4 in there. So therefore, I need to do 14 take 4, which is 10, because this whole section must add up to 14. Okay. Next, I've got 62 in total use type A. So here is type A, and all of this must sum to 62. So I'm going to leave that for later in case I have some information that I need to put into the intersection of A and C. And then it says all 20 who use type C. Okay, so I know that this, all of this must sum to 20. All 20 who use type C also use at least one of type A and type B. So, wow, I know that there's nothing in here and that everything, all 20 of type C must be in this bit. So 10 plus 4 is 14, which leaves 6 over here. Okay, so I filled that in. I know that over here, this must add to 62, all of A. So let's take away these parts here. So 8 plus 4 is 12, plus 6 is 18. And then 62, take away 18. Oh yeah, we have a calculator. So I don't even need to do that. 62 take away 18 is 44. Okay, so hopefully that made sense. We're just using the clues to fill in the missing pieces of information. And then we also have to think about how many must be in part B. So we know in total there are 100 customers. Okay, so we know all of our Venn diagram must add up to 100. So let's just quickly plug that into the calculator. 100, take away 16, take away 6, take away 10, take away 4, take away 44, take away 8 must be 12. So I've done 100, take away everything that's in the Venn diagram, and I'm left with 12. So therefore B must be 12. Okay, so now we are being asked to work out the probability from the Venn diagram. Now this question is frequently done incorrectly because people don't read it carefully and they don't know about what certain language means. So we are told that one of the customers is chosen at random, okay? But then we are told this key word here, which is given, okay? Now, given means that this is the new total. You shrink your Venn diagram. So originally there were 100 customers, but now it is given that the customer uses type A. So the customer has to use type A. So therefore it can be only out of these people. So whenever you're given the word given, it shrinks your Venn diagram. It's no longer the whole thing. So given that this customer uses type A, find the probability that this customer also uses type B. So our total is going to be out of everything that is inside here. So 44 plus 8 plus 6 plus 4 equals 62. So my probability is going to be out of 62. And then find the probability that this customer also uses type B. So here are all of the people that use type B. 8 plus 4 equals 12. So the probability that this customer uses type B, given that they use type A, is 12 over 62. So the key word here, pay attention to it, please. Okay, so some nice solids we're given here. We're told that a solid cone is joined to a solid hemisphere to make the solid T shown below. And we're also very kindly given the formulas for the volume of these shapes. Now you're told that the diameter of the base of the cone is 7 centimeters and the diameter of the hemisphere is also 7 centimeters, i.e. they're like literally attached. So the total volume of T, which is the shape, so this is called T, is 120 pi and the total height of t is y centimeters. Calculate the value of y and give your answer correct 3 significant figures. Okay, so let's think about what's happening here. We know the total volume, okay? So we know the volume of t. And how do we create the volume of t? Well, we create the volume of t by working out the volume of the cone, which we know is 1/3 times pi times r squared times h. Okay, I'm just using this formula here, plus the hemisphere. So hemisphere is going to be half a sphere. So if the volume of a sphere is 4/3 pi r cubed, the volume of a hemisphere is going to be 4/6 times pi times r cubed. I've just multiplied it by a half. Remember, timesing by a half is the same as dividing by 2. Okay, so this is my long complicated formula, and let's see what I can do. I can substitute the volume, so I know the volume is 120 pi, and I know that must equal 1/3 times by pi times by r. So r is the radius. So we've been given the diameter, so therefore the radius is half the diameter, so that would be 3.5. So 3.5 squared times by h. Sadly, we do not know what h is, plus 4/6 times by pi times by r cubed, and r is once again going to be the same, 3.5 cubed. So what we can do when we're doing things like this, and I should have probably left more space, but hey, what can you do? Is we're just looking at simplifying this, rearranging it so that you can find the value of h. Okay, so all I have done here is plug some values into the formulas that have been given. So even if this question, you're like, I don't know what to do, just look at it, look at the formulas you've been given, look at the information you've been given, and plug the formulas in. So next, what can I do? Well, all of this is numerical. So I can figure out what this is and subtract it from 120 pi. So if I did 120 pi, take away 4/6 times pi times 3.5 cubed, what would I get? So I'm going to do that bit by bit. So I'm going to type into my calculator 4/6 times by pi times by 3.5 cubed. I've got a new calculator, so all the things are... Okay, so that's how I type it into my calculator. And then I get an answer, which gives me 343 over 12 pi. So I'm going to do 120 pi take away, answer. Okay, still getting used to this calculator. So 120 pi, take away answer, and then it gives me 1097 over 12 pi. Okay, so what I've done is I've subtracted this from both sides of the equation. Okay, so I'm just left with this bit here now. So this must equal 1/3 times pi times 3.5 squared times by h. I'll just get rid of everything over here so that I can move over here now. Okay, so I'm just rearranging it, and it's just got more numbers than usual, but you've got a calculator so you can do this. Okay, so what can I do then? I can simplify this side of the equation here. So if I simplified it, so 1/3 times by pi times by 3.5 squared gives me, so I'll move over here, 1097 over 12 pi equals 49 over 12 pi times by h. Okay, so can you see I've simplified all of this, so I'm just left with some numerical stuff multiplied by h. And how do I get h as the subject? Well, I'm just going to divide both sides by 49 over 12 pi. Okay, so you do exactly the same as you would with simple algebra, it's just it's a fraction and it's got pi in it. So let's do that. So 1097 pi over 12. I miss my old calculator. I don't like these new ones. Okay, take away 49 pi over 12 equals, oh, sorry, the calculator distracted me. So I'm dividing it, so I divide it, and it equals 1097 over 49. Okay, so H equals 1097 over 49. Now, with the old calculators, and this is why I really miss them, you had this SD button, and you just clicked it and then it converted it. Now what you have to do is you press format, and then you have to go down to decimal. And this might be me not knowing the calculator very well, so if you know if there's a quicker way to do that, then please let me know in the comments. So H must be 22.3877551. Okay, I've just converted the fraction into a decimal. So I figured out what H is. Now let's see what I can do next. And H is going to be in relation to my cone. Okay, so H is this part here. So I know that that must be 22.3877. Now I also know it's a hemisphere, so I know that there must be a radius going from here to there. And I know that the radius of this shape is 3.5 because we spoke about that. So the diameter is 7, so therefore the radius is 3.5. And remember, a radius can go in any direction as long as it starts from the center of the circle. So the total height or length, the total of y is going to be H, which is 23.38 plus 3.5, which leaves me with, again, this SD thing is annoying, 25.887751, and it says give your answer correct to 3 significant figures. So that would be 1, 2, the third significant figure is here, so I'd say 25.9. Okay, so 25.9 is the value of y. So it looks like a complicated question, and loads of people just skip it because they're like, oh, it's just a confusing shape. But all you have to do is use the formula that has been given to you, manipulate it a little bit, find the missing value and do something with it. Honestly, the more you practice these, the easier they will become. Okay, so in this question we are told that the diameter of the base of the cone and the diameter of the hemisphere are both increased. Okay, so this bit here in the shape is increased by the same amount, assuming the total volume of T, so the total volume of this shape does not change. What effect would that have on your answer to part A? So remember, part A was the total height. So if we think about it, it needs to have the same volume, and one part of it has been increased. So therefore, the height, or H or T, or what were we trying to find? We were trying to find Y. So the total height would decrease because the volume has stayed the same. So if it stayed the same, then something must be smaller, because if something's bigger, if 2 dimensions are larger, then the final end product would be larger. Okay, so because the volume stays the same, the height must have decreased. Okay, so here you see some triangles that are definitely not right-angled because they have no right angles in them. And whenever you have triangles that are not right-angled, you know that you cannot use Pythagoras or normal trigonometry. They can only be used for right-angled triangles. Okay, so they have to be a right-angled triangle in order to use these two. But what you can use when it's a non-right-angled triangle is cosine rule and the sine rule, and also the area of a triangle rule. So it's really easy when you look at this. You're like, okay, I can't use trigonometry, I can't use Pythagoras, so therefore it's going to have to be cosine or sine. If it was a right angle triangle, then you could use Pythagoras or trigonometry. So let's have a look at what's happening. And maybe I'm just going to write my sine rule and cosine rule here. So my cosine rule is a squared equals b squared plus c squared. Oh, it's not big enough. Let's do it here. A squared equals b squared plus c squared minus 2bc cos a. Now, if you know how to if you memorize this and you know how to memorize the rearranged formula, that's great. But if you don't, then we'll go through this here. And then the sine rule is just a over sine a equals b over sine b equals c over sine c. And of course, these can be flipped. So it could be sine a over a equals sine b over b. What the key thing is that the little letters, they represent the side, and the big letters, they represent the angle. So it doesn't matter which order you do. So PQR and QRS are triangles, and you need to calculate the length of QS. Okay, so this is our ultimate aim. So generally when you're given two triangles, you're going to start with a triangle that you don't want the end result to be on. So we're going to start over here, because normally you work on this, you figure something out, and then you use that for your next triangle. So we have been given a nice angle over here and two sides, which is really nice. And what do we want to work out? Well, it would probably be helpful to work out this side over here, because I'm not really interested in angle here or the angle there, to be honest. So bearing that in mind, if I want to work out this side, I'm going to use the cosine rule. Okay, and what I want to do is label my triangle accordingly. So cos A means A is going to be your angle. Therefore, this little side is going to be little a, and that's convenient because you are trying to find out a, the little a, the side. So label everything else. This could be little b, this would be big B, but it doesn't really matter because you're not using the angles for the cosine rule. So if I wanted to work out a squared, what do? I put in b squared, which is 11, plus c squared, 9.4 squared, take away 2 times by b, which is 11, times by c, which is 9.4, times by cos a, and the value of the angle is 27. So all I'm doing is plugging those numbers into this formula. So let's do that bit by bit just to show you. So 11 squared, take away, plus 9.4 squared equals 5, 2, 3, 4, take away 25. And if you're not particularly confident with your calculators, then just do it bit by bit. So then let's do 2 times 11 times 9.4 times by cos 27, which is 184.2601492. So you know that a squared is 5234 over 25. Take away your answer, which is a squared equals 25.0998508. Okay, so therefore I can square root that to find the value of a. So a is 5.009975129. Okay, so let's get rid of all of this here. And I would encourage you to probably work in pencil so that you can rearrange your triangle in terms of what you label it, but it's up to you. So I know that this is going to be 5.009975, so forth. Okay, and I am trying to work out, I haven't been given any sides apart from this side, but I am trying to work out this side here. Now, let's label this triangle. So I could label this A and this little a. I could label this B and this little b, because when you're labeling your triangle, essentially the side and the angle have to be opposite each other. And remember, the little letter represents the side, the big letter represents the angle. And then you've got C over here. So that angle you don't know, but this would be the side C. So because I have got a side, which is 5.009, so forth, and I've got an corresponding angle, so I've got the angle for big A, that would be sine 41. That must be equal to B, which is what I'm trying to find, the little side, over sine 88. Okay, so that's why I label my triangles, because then I know what to fill in. And I use the sine rule because I've got two sides, two angles and a side, and I'm trying to find the final side. So let's see what I can do. I just want to rearrange this. So what am I going to do? I'm going to multiply both sides by sine 88. It's just like rearranging algebra. It's got some trigonometry in it. So if I type this into my calculator, I'm going to save the answer from before so that I'm super accurate. So 5.0099 blah, blah, blah over sine 41 multiplied by sine 88. So that's how it would look like. Equals 7.631818 blah, 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 blah. It tells you to give your answer correct to 3 significant figures, so I don't need to write all of those decimals out. That's 1, 2, the third significant figure is here, so that would be 7.63. Okay, so here I've got some functions questions, and they're really literally just, for the first part, the easiest kind, of just substituting. So I'm told that the functions g and h are such that g of x is this, okay? And I'm being asked to find g of 16. So all I need to do is wherever I see an x, I substitute 16. So can you see why? So g of x is this, and I want to find g of 16. So wherever I find an x, I'm going to substitute 16. So g of 16 is going to be the cubed root of 2 times 16, take away 5. Okay, so I could simplify that before putting that into my calculator if I want. So that would be 32 take away 5 is 27. And actually, I don't even need to use a calculator for this because the cubed root of 27 is 3. But of course, if you're not familiar with the cubes, then use a calculator. Okay, so this is a slightly tricky question because you're being asked to find an inverse composite function. So when we deal with functions like this, what we always do is we start from the inside. So first what I want to do is find the inverse of g. And the way I do that is by setting it up. So I'd say y equals the cubed root of 2x minus 5. And what I'm trying to do is rearrange it to get it in the form x equals. So the first thing I could do is the inverse of the cubed root is cubing. So y cubed equals 2x minus 5. Then I could add 5 to both sides. So y cubed plus 5 equals 2x. And then I would divide by 2. So y cubed plus 5 over 2 equals x. Now the final part is to just switch your x and your y around. So y equals x cubed plus 5 over 2. And instead of y, what you're going to say is g minus 1 of x equals x cubed plus 5 over 2. There's videos that I go into the whys about this, but it's quite a long explanation for an exam video. So that's g minus 1 of x. And then what I want to do is put this function into h. Okay, so wherever I see x, I'm going to put g minus, I'm going to put this essentially. So h of x is 1 over x. So wherever I see x, I'm going to put this. So it's going to start by being a little bit of an ugly thing. Not ugly, but clunky. So 1 over x cubed plus 5 over 2. Now, when I'm doing this, remember you're just doing, it's just a fraction. So that's the same as saying 1 divided by x cubed plus 5 over 2. And when you're dividing fractions, you change the sign and you flip the fraction. Okay, so you're actually saying 1 times by 2 over x cubed plus 5. So therefore, hg minus 1 of x is going to be 2 over x cubed plus 5. So I'll write it here as well. 2 over x cubed plus 5. Okay, so here is a circle theorem question. Now, once again, circle theorems are just about using the knowledge you know, thinking about all the things you know, all the circle theorems you know, and how you can apply them to this question. So we're told that A, B, C, D are points on the circumference of the circle, centre O. A, D, E, so A, D, A, D, E, and B, C, E are straight lines. Okay, so that's good to know. And we want to work out the size of angle CDE. So this angle over here. Okay, so let's think about all of the things that we do know. Well, over here, you have the circle theorem of angles at the center are double those at circumference. So hopefully you saw that. So we could figure out what this here must be. Half of 132 is 66. So we know that this angle here must be 66. Okay. Next, we know over here, this is a quadrilateral. And because all 4 of its vertices are touching the circumference, it's a cyclic quadrilateral. And I know that opposite angles in a cyclic quadrilateral sum to 180 degrees. So therefore I could figure out what this angle here is. So 180 take away 66 is 114. So that's 114 degrees. Now this over here is a straight line. So you don't even need a circle theorem. You just need your basic geometric facts. You know that angles in a straight line sum to 180. So therefore 180 take away 114 is 66. And there's loads of ways you could have done this. This is just one of the ways. So that's 66 degrees over here. Now, over here, is this a triangle? Yep, I believe it is. And you know that angles in a triangle sum to 180. So therefore, and also I'm writing these because what does it say? Give a reason for each stage of your working. So it's great if you figure the answer out, but if you have not given your reason, then you cannot get the marks for reason. So this is why it's so important to know your angle facts and your circle theorems. So 180 take 66 take 16. 180 take 66 take 16 is 98. So over here I have got my angle CDE equals 98 degrees, and my reasoning is, I mean, if I were you, I would write the reasoning a little bit better. So angles at the center double those of circumference, therefore angle BAD equals 66, and do it that way. I should have done that really. So opposite angles in a cyclic quadrilateral sum to 180, therefore angle DCB equals 114. Just to be on the safe side. Yeah? Okay, so here I have a graph transformation. I am given the graph of y equals f of x, and I am asked to sketch the graph of y equals f of negative x. So because I have a negative sign inside the brackets next to the x, what that means is that all of the x coordinates are going to be flipped. It's going to be the negative version of them. So let's have a look at my x coordinates. So I've got one over here. This graph has no scale. So let's just quickly give it a scale just so that we can see what we're doing, and we do an equal amount on each side. So that would be -5, so I could flip it to +5 would be my first coordinate. Then my next coordinate is over here, -3, so it'll be here at +3. The y coordinates are not changing. The only transformation that is occurring is that the x coordinates are being flipped. Then you've got another x coordinate over here at 1. Then you've got your final one here and next one here. So I'm just going to remove all of the original x coordinates and join up my line. So straight over here, up. And I should have plotted that there. I don't know why I didn't. It's 5, 0 because the y coordinates don't change. So all you're seeing essentially is a reflection in the y-axis. So here I've got a trigonometric graph transformation. I am told that here is a sketch of the graph y equals tan x. So the first thing that I could do is just think to myself, okay, what do I know about the graph y equals tan x? Hopefully you know how to sketch it. So you know it goes from -90 to 90 and then it repeats. So the next part would be 270 and so on. So just having that in the back of my mind can help me. Now let's read the next part. So it says the graph of y equals tan x is translated. So moved, it just means it's going to be moved up or down the x-axis and the y-axis to give the graph y equals g of x. And following the translation, the point Q shown on the graph above moves to point R, which has the coordinates 90, -5. So if I label my graph first of all, I know this is going to be -90, this will be 90, this will be 270. And therefore, point Q is going to, like each little part here, that would be 180. That's a distance of 90, so that part here must be 360. So therefore, the coordinate of Q would be 360, 0. And I know that the point Q is moved to create the coordinate R, which is 90, -5. So essentially, the graph is kind of, oh, that's a really poor sketch, been translated like this. Okay, so what have I done in order to get that? Well, let's look at what happens in the x-axis first. I've moved from 270 to 90. So all of my x-coordinates are shifted over by 270. So therefore, over here, I've got the graph y equals tan x. And what I can do is just say tan x plus 270. Now, the reason I do that is because anything I put inside the bracket is actually the opposite of what is happening. So because I'm saying add 270, what I'm actually doing is all the x coordinates are subtracting from 270. So whatever goes into the bracket, inside the bracket, you do the opposite. And then what am I doing with my y? Well, I go from 0 to -5. So I'm just shifting it downwards by 5. So I'd say y equals tan x plus 270 and then take 5. So find an expression for g of x in terms of x. You'd say g of x equals tan bracket x plus 270 take 5. Okay, so the last question of the paper, here I have been given two quadratic inequalities and I'm asked to find algebraically the set of values of x for which satisfies both of these inequalities. So let's start with the first one. I can see it's x squared to take away a square number, so I know that it's the difference of two squares. That happens when you've got x squared to take away another square number, and your answer or your solution is always going to be x plus y and then x minus y. So in this case, I know it's going to be x plus 7, x minus 7 must be greater than 0. So if this was just a normal quadratic, not an inequality, the solutions would be x is -7 and x is 7. And what I want to do is just draw myself a quick sketch so I can figure out where exactly this graph, where the y values would be greater than 0. So I've got -7 here and 7. I'll just draw a quick quadratic. It's just a sketch. You don't need to worry about anything. Just literally draw the sketch. And then where is this graph? So where are the y values greater than 0? Well, obviously everything under here, the y coordinate is less than 0. So it can't be anything in this region. Therefore, over here, anything that is over here, the y coordinates are greater than 0, and similarly over here. Therefore, I know that x must be less than -7, because it's going in this direction over here, or x must be greater than +7. And that's my solution to the first inequality. So let's just write that up here. For the first inequality, x must be less than -7 and greater than 7. Then what I can do is move on to my next inequality. So let's have a look. It's I could either factorise it normally, or I could use a quadratic formula. I'm just going to go with the quadratic formula. So I know that my a value is 5, my b value is -31, and my c value is -72. Remember, every quadratic is written in the form ax squared plus bx plus c equals 0. And then I can use the quadratic formula. So I'm going to say x is -b plus or minus the square root of b squared take 4ac all over 2a. And I can substitute my values in nicely because I've written them all here. So x must be minus b, so minus 31, plus or minus the square root of b squared. So I'm just going to write 31 squared because I know a negative times a negative is a positive. Take away 4ac, so 4 times by a, which is 5, times by -72, and this is all over 2 times 5. So now I just simplify it. You could whack it into the calculator. I'm just going to show you what it would be. So that would be 31 plus or minus. Now let's do this in two parts. So 31 squared gives you 961. And then 4 times 5 times -72 is a minus 1,440. And just be mindful over here, you're subtracting whatever's in this bracket. So therefore, two negatives make a positive. Subtracting a negative gives you a positive, so you'd add them. So let's simplify it even further. That would be 31 plus or minus, and then we do 961 plus 1,440 equals 2,401. I'm just doing all of the steps so that you can follow along if quadratic formula isn't your forte, and also so that you can see if you've spotted where you may have made a mistake and rectify it. So then I've got this. I know I'm going to get two answers as always with a quadratic. So if I just type into my calculator 31 plus the square root of 2,401 divided by 10, I end up with 8. And also if I then just move things around and I put subtract, I would be left with minus 9/5, which as a decimal is minus 1.8. So once again, I could look at my graph. If it was this graph, so the equation of y equals 5x squared minus 31x minus 72, it's going to have its solutions at negative 1.8 and 8. So look roughly like this. And I'm interested in knowing where the graph is greater than 0. So once again, this over here and here, the graph is greater than 0. So therefore, the solutions to this would be x must be greater than 8 and x must be less than negative 1.8. So I could write these up here. So for my second graph, in order to satisfy the inequality, x must be less than minus 1.8 and also x must be greater than 8. So now I can look to see which what would satisfy both of these inequalities. Okay, so that just flipped out somehow. So if I just draw just a quick sketch of my graphs. So remember, I've got one of them where it's 7 and negative 7. And then for the other one, I've got minus 1.8 and 8. Okay. And for these inequalities to be satisfied, it needs to satisfy both of them. So therefore, nothing in this region here works. Okay. So let's just get rid of all of that. Oh no, I got rid of the graph too. Okay. So therefore, The only thing that can satisfy both these inequalities is anything that is less than -7, because it needs to satisfy this graph and this graph. So over here, this is satisfied by the graph of, by the x is less than -1.8, but this part here wouldn't be for this graph. So therefore, my final solution must be x must be less than -7, okay, because this part here only satisfies this graph. And similarly, over here, anything above 7 would satisfy this graph, but I need them to satisfy both. Therefore, x must be greater than 8. And that's your final solution. So x must be less than -7, and x must be greater than 8. So anything that is greater than 8 or less than -7 is satisfied by both of your inequalities.